Okay, we're gonna be doing some easy LeetCode. So let's find the next easy. Go to problems. And we'll find something easy. Add binary. Let's open it up. Add binary. Given two binary string. Okay. So we got to make sure that we carry the one over. Okay. So we've kind of done a similar problem. To me, we kind of have to work our way from the right to the left. So let's write that loop. Let I equal the only question, I guess we'll say 0. I is less than, we'll say const length equals math dot min. I will keep track of the sum here. I'll just keep it as an array. And we'll do a dot length, b dot length. I is less than length. Basically, we want to sum all of the bits that we can. So we'll say the only question is, I think at the end we're gonna do return sum dot join with an empty string. I'm trying to draw a line as to what is cheating versus what is honest. So to me, cheating would be converting these strings to a number using a built-in function. But I think that summing here is fine. So we're gonna have an extra step at the end where we carry. But we'll say to do carry. Sum the bits. Sum the bits. So we want to get the rightmost bit from A, which would be A sub A dot length minus 1 minus I. And then we could do right equals B So basically we're just like aligning the back ends of the binary numbers here. And I'm trying to avoid using a built-in function to determine this number. So my idea is if left equals 1 and right equals 1, then we'll sum dot unshift 2. Else if left equals 1 or right equals 1, we'll sum dot unshift 1. Else they're both 0, so we'll unshift 0. And unshift is adding values at the beginning of the array. So we're basically building the number as we sum it from the end to the beginning. So the most significant value of the bit of the binary string would be towards the left, which is why we use unshift. But as you can see, we're putting the number 2 into a binary number. Another step that we didn't do is add the remainder of the bigger number. And so basically we're going to have to do, we'll call this min. And then we'll do const max. And so we want to do for loop, let I equal min, I do we have to do that? Let's do this. Let's say we might just need min greater than or equal to 0. No, let's do that. Let's put the max in there. I is less than max. I plus plus. Give me a moment. Okay. And pretty much if we can do this. Just give me a moment. I'll be right back. I forgot to plug in. Hello? Okay. Sorry about that. I forgot to plug in my Ethernet. So we should be back on. Cool. Okay, let's continue. So we basically want to complete the string here. I guess in theory we could just do it in one loop actually. Because JavaScript lets us. We just say we can actually just call this max. Because in theory, when we get the left and the right, if they're undefined, then they're not going to match either of these. So I think it's actually fine to just do this all in one loop. And then we have to do the carry operation. I is less than sum.length. The only question after this is, can we actually do it just in one loop? So we'll have to say if sum dot length minus 1 minus I is 2, then we have to say equals 0, and then plus equals 1, carry over the 1. This should get us a pretty close result, a close answer. So we're gonna try it. Okay, we have a failing case. Oh, interesting. Alright, this is an edge case. Did not consider. And this is an edge case I did not consider. So basically this idea of carrying beyond the first index. There's kind of two ways we can do this. Let's say const index equals this. If index is greater than or equal to 0, index else sum dot on shift 1. I should resolve it, but I would consider that this is possibly not optimal. So actually we got a minus equals 2. Okay, well that's interesting. Let's do console log of the sum at this point. Oh, this greater than or equal to 2. Okay, we probably don't need to log actually. Sum it or submit it. Okay, so it is not optimized, which is expected. So we gotta kind of think about one thing we could think about is actually building the binary number from left to right. Rather than right to left. So one thing I would want to try is we're still going to go from here, but we're going to say sum.push. We can do this. Let's do this. Const val equals input equals 1, otherwise 0. So we'll do val and val. That way we can simplify this a little bit. and we'll say const current equals the value of a sub I. So it'll be if left plus right plus current is greater than equal to 2. Else. What to say sum sub I equals left plus right plus current. If they are, we can get rid of all this. I guess unshifting is pretty slow, and now that I think about it. So of course we're going to end up in this lower echelon. If this is the case, then sum sub I equals left plus right plus current minus 2, and sum sub I plus 1 equals 1. And now we have the dot reverse it. Rerun it just to see for a few test cases. And we get 1 0 0. We do console log left, right, current, sum, and run it. So it needs to be 101 and we're giving it 100. So we're thinking about this. Oh yeah. No, yeah, this is fine. Starting from the right. Yeah, that's logical. So left is 1, right is 1, and then left is 1, right is 0. Oh yeah. But why is the current 1? That's why is the val function returning 1? That's odd. Oh, why am I putting A here? Okay. That should resolve that issue. Alright, what do we have? Another issue. What is 10? Expected 100. Okay, put the log back, I guess. And then we end up with 1 1 0, which should carry, and then it did carry, but we should take 1 and 1. Do that. We should, for this one, we should go down this route. Excuse me. And then let's run it and see, make sure we're going down this carry route. We do carry, but then we don't carry. Actually, the current is 0 here. The current should be 1. Let's console log I. Because the left is 1, which is nice. The right is 0, which is correct. Current is 0. Sum sub 1 is 1. So why is current? Oh. We should do this. Run that. Okay. Alright, now the question becomes, can we... Well, let's see where we landed. We are at 6 milliseconds, hardly beating anyone. What just happened? Oh, I clicked the wrong button. I clicked solution by accident. Excuse me. This is slower? Doing 1 loop is slower than doing 2 loops? That's interesting. I guess we could do like const total equals do that. Oh, why are we console logging? How is the console log so expensive? That's crazy. Alright, let's try to consider what else could be expensive here. I would only suspect that calling a function is slow. I actually wonder if we could do array.from length is max plus 1 so that we have a fixed array size and there's no like as the array grows there's some kind of re-arraying. We could probably also do this, and then we can do this. Just minor sub-optimizations that actually make it run. I guess let's go back to this. Try submitting this. Okay, so the else, having the else was better. It's not always just about having less code. Okay, it just seems like it's random. We will avoid calling a function here. Get rid of that function. See how much overhead. To me, this is probably the slowest part now, but I don't really know how to make it faster. The only thing I could think of doing is manually reversing and concatenating the string, but that seems slower because reverse is going to be native. So I think that's the best what we can actually do. At least with JavaScript, I guess. But I think it'll be a good idea to look at other solutions. Okay, well, yeah. The best solution is a solution that cheats, which is fine. So they convert the two numbers to binary, from binary to begins. They add them together and two-string them back to binary. That's a solution, but it's not really a solution that a company is looking for, that an interviewer is looking for. Okay. So they are going from the end of the string, keep a track of a carry, and the result. I'm actually surprised that this would perform better because string concatenation is expensive. But this is a cool idea. As long as there's numbers to process, we add the number, we parse the number. I also thought that this would be slower as well. So I'm a little surprised. They're doing so much extra. I'm a little surprised that this is actually better than our solution. This person interestingly tried to do on shift as well. But unshift, like I said, it's slower because unshift is a big O(n) operation. It's like we end up with an n squared here, so it's not optimal. Now again, I'm surprised that parsing is faster than an equals check. That's kind of crazy to me. But yeah. That's the solution. I actually have an interview right now, so I'm gonna just hop off for 30 to 60 minutes and then I'll be right back after that. Alright. Thanks for joining for now. I'll see you all in about 60 minutes. Bye for now.